When I was developing the first circuits and actually making them into a product, I decided to do three different products. The first one I did was a high voltage power supply only for the DPA microphone. So it had two channels of 130 volt powering, and I called that the HV1. The HV2 was something in between, and I don't remember. I'm not sure if it ever really became a product. And the HV3 became the full-blown mic preamp with 48 volt phantom power, 130 volt DPA powering, two mic preamps, power supply, everything integrated into one box. That was the original HV3, and that sort of just stuck as the product evolved into different packaging. It was the same preamp, just packaged differently, so we've always called it the HV3. When I started recording the symphony orchestra, the Sacramento Symphony, I was using another type of outboard mic preamp and not really achieving the results I was looking for. It was quite colored. And having a background in audio engineering and product design, including preamps and other things in audio, I thought, I might be able to do a better job than this. So the next couple of years, I experimented with circuits. All types of mic preamp circuits, everything I could find in the literature, and then some of my own design, hybrids, and within that 2 years I learned a lot about mic preamps. The HV3 was the best circuit that I could come up with for neutral, accurate, invisible sonic performance. And that's how it became my preamp for classical music recording. Later on, people started buying it. Friends were calling, engineers were calling, and it became a product, and then I started making them for other people. Today the HV3 preamp is now used all over the industry. A lot of classical music people, but also a lot of pop music, film scoring, Foley, ADR, voiceover, drum work. It's becoming very popular for multi-channel drum work in pop studios because of the clarity and the invisibility to transient response of the drums. When a snare is hit, it sounds like the snare. There's no coloring or smearing of the image. It sounds like the drum set. The HV3 audio circuits run off of 50 volts, which is also considered somewhat high voltage in mic preamps. It gives a much higher dynamic range than most other mic preamps in the industry, which are running off of, say, 36 volts, or some even 30 volts, some even less than that, 24 volts. The 50 volt operating circuit gives us 32 dBu of output headroom, which is enormous. Very few pro audio devices will even get close to running at that sort of level. And the input headroom, unpadded, without an attenuator on the HV3, is plus 23 dBu, which is also extremely high. It's basically line level. So you could run mics or line level into the HV3 without a pad, and it would be very happy. What this means is, at least in my theory of design, I like keeping a very high dynamic range so that the signal itself never gets even close to the rails, to the high voltage rails. The signal remains here in its peaks while the voltage rails are up here. In electronics, there's a general rule that as you start approaching your voltage rails, as you start getting very close, you start running into nonlinearities, distortions, slewing-induced problems, on and on. I like to avoid that. It may or may not be a problem, we don't know, but it's a good rule of thumb when designing audio circuits to keep your audio very far from your voltage rails, so you're always operating within a very nice linear area. And that's one of the reasons the HV3 has high voltage power supplies. The HV3 is a truly balanced circuit. This means that pin 2 and pin 3 of the XLR each have their own set of amplifiers. And those amplifiers are mirror matched all the way through the circuit. The microphone never unbalances from input to output. Most mic preamps unbalance the microphone going in, do the mic preamplification, and then rebalance the circuit going out. When you do this, you need something to unbalance and something to rebalance, some sort of circuit. That's usually a transformer or some electronic circuit. The HV3 doesn't need that. When you consider that most other microphone preamplifiers are using either a transformer or some sort of electronic unbalancing and rebalancing circuits, you realize that it introduces another couple of layers of sonic muck. You can't get around it. You have to go through those gatekeepers at each end. Because the HV3 is fully balanced all the way through, it avoids those extra couple of layers of sonic muck. There's no gatekeeping. When the microphone enters the circuit, it goes right directly into the gain stage. It hits the base of the transistors in the front end of the mic preamp circuit. Nothing else is in the way. And on the back end, it's truly a current source. It's a driver. There's nothing else there to rebalance the circuit. It's already balanced. When I was designing a preamp for my own use, which became the HV3, I tried a lot of transformers. Medium range, medium grade transformers, high grade transformers, in a number of different topologies. I was never satisfied with the results that I achieved with transformers. The main problem is at low frequencies and high dynamics. At low frequencies, the transformers became very apparent, say with pipe organ in a church or an orchestra. Down in the 30 hertz region for a pipe organ, transformers didn't sound right. You could hear them. Also, in very large dynamic peaks of an orchestra or drums or something, you can hear the ringing of the transformer. At least I did in my tests. Transformers are very good for a lot of things. They do a lot of things very well. The things that I need for classical music, they tend to be a limiting factor. That's why I didn't use them in the HV3. Now, in some other products that we make, there is a transformer for various reasons. The Origin is a good example. In the industry today, there are just myriad of products that employ transformers. Most of them are there for color, for personality, for the nonlinearities that they produce. People like, especially pop music, people like the sound of transformers. They ring, they distort, they go nonlinear, and sometimes what that does to music is very exciting. And it creates a color that you couldn't achieve without the transformer. In the Origin product that we manufacture, it's been very successful. We have a transformer in the front end for that purpose. It's switchable. You can put it in the circuit or you can take it out depending on what you want. When it's out, it's a very pure linear signal path. When it's in, it gives you a boost in the low frequency range, and it's not just an EQ boost that's a very smooth curve. It's a boost that has a very sharp leading edge right around 100 hertz and then tapers off like this. It's a ringing in the transformer. It's caused, I believe, by inductive leakage. So it's not all that great a transformer, but the sound it gives, especially to say kick drums or a floor tom, is amazing. When you hit that drum, it just doesn't go boom, boom, boom. It goes boom, boom, boom when the transformer's in. It's a great pop sound. So transformers, they're wonderful. They're used all over the audio industry. They're a very good thing for a lot of reasons. For accuracy, I personally avoid them. There are more and more people these days using ribbon mics, myself included. I really like what a ribbon mic can do, especially to concert band, horns. They have a way of smoothing out a horn sound without muting it, giving it a softer, more gentle, but still very musical and rich sound. There's a lot of people using ribbon mics, but they have a very low output, so it's hard finding a preamp that responds correctly with ribbon mics. The HV3 was designed to have high gain while retaining a very high signal-to-noise ratio. So at high gains, medium gains, low gains, the HV3 does very well. Dolby, in fact, called me one day. They were looking for an 8-channel preamp, but they were trying many, and they couldn't find one with high gain and sufficiently low noise. They tried one of our 8 channels and called me back and said, well, we found our preamp. When using ribbons, you're always going to be typically always using high gain, unless it's right in front of a guitar amp cabinet or something, which then your gain will come down. But especially in acoustic applications, you need a lot of gain. The Millennia gives this sort of high gain without messing with the timbre response of the preamp. It stays open and transparent at any gain level. This is another reason people, especially in the acoustic world, really like it. In a transformerless microphone preamp, you still need to block the phantom power coming in. I do that with capacitors. There's really only 2 ways to do it, transformers or capacitors, to keep that 48 volts from coming in. When I use ribbon mics, I typically need up to about 55 dB, maybe 60 dB of gain. Really no more than that. But some customers need more. They're recording a much softer program and perhaps backing the mic off a bit more than I normally would. They may need 70, 75, 80 dB of gain. It's a lot of gain, but if they need it, we can offer that. It's a free option we give to all of our customers. They buy a preamp and they need more gain, we'll give them more gain. It's a custom gain option that we do on all HV3 type preamps. We do it in the Origin, HV3C, HV3D. When we do the high gain option, even if we go up to 80 dB or more, I've done preamps at 100 dB, 80 dB still retains a very good signal-to-noise ratio. Nothing falls apart. The imaging, the timbre, the invisibility of the preamp remains very solid. So if you need 80, 70, 80 dB, we can certainly do that. Especially with the advent of ribbon mics now, you see more and more people using high-grade mic preamps, outboard mic preamps with dynamic microphones. Phantom microphones require some sort of blocking at the input to the mic preamp. This is done traditionally with transformers or capacitors. Either way, the transformer or capacitor, you're going to add some level of circuit muck. Every time you put something in a circuit, you get a little bit of muck. Sometimes you get a lot of muck. A transformer, to me, would be a lot more muck than a good capacitor. But in seeking to avoid that with dynamic mics, I've developed a bypass option that takes the input from the XLR when using dynamic mics that don't require phantom, especially ribbons. The bypass goes directly from the XLR input to the bases of the input transistors, bypassing entirely the RC network at the front end. And this does give a slightly improved sonic performance with dynamic and especially ribbon mics. Years ago, when I started doing classical music recording, I realized that I would very often like to sum different channels of my mic preamp, summing left, summing hard right, and so forth, with various microphones, more than 2. So I developed a passive summing circuit that would passively sum a number of outputs on my HV3 preamps. You can't sum passively a whole lot of outputs without getting into severely